Hello students, on continuation of AC fundamental circuits, we will continue to learn the relation between voltage, current and resistance in simple circuits. Okay. So, what we have seen in previous classes, we have seen what is the resistance. Resistance is a property of the material which can oppose flow of current through it. What is the inductance? The property of the coil that opposes any change in current flowing through it. Capacitance, this property of the capacitor which can always opposes any change in voltage across it. Resistance unit is the ohm, inductance unit is the henries, capacitance unit is the faradays. Now, this converted into ohmic value, resistance into ohmic value, only always the ohmic value, and whereas a Henry is, if frequency is given, then it becomes the XL, that is equal to omega L. Okay. So, that is omega L is equal to 2 phi f L. Okay. So, what is the unit final ohm? It becomes to the unit is ohm. Now, coming to the Farads, then becomes the Xc, capacitive reactance, that is equal to, that is the megastar second order, that is equal 1 by omega C, that is equal to, we can write it 1 by 2 phi f C. What is the unit? Ohmic value. Okay. So, we have seen previous classes how is converted this normal components to ohmic components, and we have seen that circuit how the I and voltage and impedance, what is the power, what is the reactive power. This is mother, this is father, this is the total family history. Okay. That is equal, we can write it, where this is a grandfather and she is the grandmother. We have seen. Okay. So, how the these four fellows affect on their kids, that is equal to resistance and inductance girl, and another girl is the capacitance. We have seen last class what is the impact of these three behavior on parents and grandparents. Okay. So, what we have seen here, so that is equal to I, the current mother is equal to V by total family effect. So, what is the Z? Impedance. Okay. Impedance we have seen. What is the unit? Ohmic value. What is the Z? Z is equal to R plus J of X. So, last class we have seen impedance triangle also. So, this is equal to R in phase with the voltage here, that is called X. So, we can write it, this is equal to Z, angle is the phi. This is the impedance triangle. Okay. So, what is the X? X is equal to, I can write it here, X is equal to, I can write it XL XC. Okay. So, whatever the big value you have placed in the starting and subtract that thing. Okay. Where is the XL? XL is equal to, just now we have seen the omega L, that is equal to phi f L. X is equal to 1 by omega c, that is equal to 1 by 2 phi fc. Okay. So, ohmic value and ohmic value, and at the same time we have seen that the power is equal to V into I into cosine angle between these two, whereas the reactive power is equal to V into I into sine angle between these two, we have seen. And power angles also we have seen that this is the active power kilowatts and this is the reactive power kVARH, reactive power, okay, kVARH, and this is the power we can take kVA, active power, reactive power, apparent power. This is the phase angle. So, this is the power triangle. Okay, this is the impedance triangle. Impedance triangle. Okay, so last class we have seen all these things. Now, I want to see the what is the behavior of simple circuits. Now, in this class I am going to concentrate my idea on pure resistance, connected in the circuit. That means here the person who is my son is a heir to my total Khandani. I want to know the what is its behavior. Okay, what is its behavior, that is equal to resistance. Two words is father, two words mother, two words is grandfather, two words grandmother. I want to know that its relation between these three. Okay, so let us see now. Here pure resistance only at the time of single person, only pure resistance, no combination of resistors resistance. Then resistance. Now let us see. Here I connected this resistance, okay, through our AC supply. Then here I connected my instantaneous values voltage, and this is equal to R, this is equal to I. Now what is the V? Here V is equal to V RMS is equal to V max sine omega t. This is a function of in frequency. Okay, omega is equal to 2πf frequency. Now what is this current behavior at that resistance connected in single? Now here we are going to see the relation between the voltage, current, resistance, father, mother and son. If you draw the vector diagram, so vector diagram, if you draw the vector diagram here, for example, if we take his father is now okay, now father is the what will happen in this case is the son, that is a V, son. So when son starting, the person is a bigger one, is a first person, so everyone is a happy, voltage is father and mother, everyone is happy. So in this case is what is the relation between the is mother and father. Now is the father is always sinusoidal, his behavior is the same. If we taking this one is the omega t, and you can take here is the father, at the same time you take the mother. So what is the relation at starting stage is the first kid in the family, and mother and father is both are happy. At that condition, mother relation and father relation are very good and coordination each other very perfectly. So that means the mother are also in phase with his father. So here correct. That means the father may be the bigger age, mother may be smaller age. Difference may be the 3 years. So what is the at that condition? For example, here you can take the 0, 5 by 2 and 5. This is a 2, 5. What is happened here? At initially the mother and father is a close each other. Okay. Now you can take green. Okay. Now what is happened? Your father is a maximum at that 90 degrees. At that condition is the mother also 90 degrees maximum. Once father becomes a 0, mother also becomes a 0 in phase. Now here also it's a negative side. The father is a maximum here, negative side. Mother also maximum in negative side. They becomes a 0 here, both becomes. So both are in phase. Here voltage and current is the same. They are the coordinate each other, correlated each other. They are the just like Rama and Sita before going to the Vanavas. Okay. After that also they are the in phase. Don't worry. Now the voltage and current is the in phase. Both are coordinate each other. Happy family. The first person is, that is the son. Now voltage and current are both are coordinate each other. Okay. This is the behavior. Now I want to know the relation. What is the current value at that condition? So here the mother is the very happiest. Okay, happiest. Then I want to know that what is the relation at that condition. So I is equal to, I can write it here. Here. So V is equal to becomes the small v is equal to maximum Vm sine omega t. This is the father, and this is the resistance is son. Okay, here the father and here is the son. Okay, at that condition, what is the behavior of her mother now? That is equal current value is equal to how much? I want to know. So they are happy. Now, so based on the father and mother, I can find that I is equal to the current is equal to, I can write voltage by resistance. What is the voltage? So voltage is the behavior is the Vm sine omega t by resistance. Okay, then what is happened? So that is equal, I is equal to Vm sine omega t. So that means here I is equal to, I can write it. So V by M, maximum by father by son is equal, I can write the maximum Im. When it becomes the maximum, current is becomes the maximum when the father becomes the maximum value at that condition. So she is also becomes the maximum here. When it is possible, when theta is equal to 90 degrees. When theta is equal to 90 degrees, what will happen? Sin 90 is equal to 1 at that condition. So V becomes the here. So whatever the value sin omega, this becomes to the 1. Then we can write it the Vm by R. So that becomes the Im, maximum current it will occur. Okay. So that value I can write it here, Im sin omega t. This is the father mother behavior. Okay, so this is the father and at this condition mother. Okay, now what we have seen here, so here father and mother are in face each other. The quarrel between disputes between the father and mother is 0, and what we require to is grandfather relation now. Okay, let us see that one also. So we have seen that, so V is equal to Vm sine omega t and I is equal to Im sine omega t. So this is the first equation father, this is the second equation mother. Now based on these relations they have to find that what is the grandfather behavior power. I want to know the power value. We know that what is the power? Power is equal to V into I, RMS values. Now substitute. So father will attend to his father sine omega t and mother Im sine omega t. Okay, so then what will happen? So here Vm is a constant, Im is a constant, then sine omega to sine omega. We can write the sine square omega t. So we can write it in the form of, so Vm Im, we can write that is the 1 minus, okay, so what is the formula? Cos 2 omega t by 2. I can write it in trigonometric form. Okay, then it what will becomes Vm Im by 2, okay, 1 minus cos 2 omega t. Here is the double the frequency. Okay, that becomes a double the frequency. Now in this case I can write it here Vm by root 2 into Im by root 2 I can write, because root 2 is becomes 2. Okay, then I can write 1 minus cos 2 omega t. So I can write it, so Vm by Im is called, we already know the RMS value, Vrms, simply RMS value. What is the RMS value? So Vrms is equal to, okay, so Vmax by root 2. We have seen that here V becomes this value Vrms into Irms, normal recurrence, into 1 minus cos 2 omega t. Okay, so this is the power. Now here what is happened? This is a double frequency. Okay, so that value, so double frequency value is the average value of this full cycle for this one becomes to 0. Okay, so what is the average value? So I am going to this one, here the positive is same, negative is same. So whatever the area of positive equal to the whatever the negative area, then average of this is equal to the 0. So here the double frequency, then this becomes to the 0 value at value. Average value of the full cycle is 0, then it becomes 0, then we are going to get it. So P is equal to, simply I am going to get it V RMS into I RMS only. So into 1 you are going to get this becomes to the 0 at full scale. Then we can say is equal, power is equal simply V into I, simple equation we got it. Okay, so dear students, this is the behavior of pure resistance connected in the circuit. Okay, so frequency of the fluctuating power, so this already we have seen. So this we can say the P Vm by this value into this value, that is the, it becomes the 0 at double frequency. Okay, so what we have seen in this case in pure circuits, let us conclude it. So we will see one by one circuit details. So what we have seen here, the relation between voltage and current. Okay, so relation between voltage and current, both are in phase. First point, both are starting and ending in phase. And the phase angle between voltage and current. So what is happen? P is equal to V into I into cos phi. Its angle is 0, then it becomes the V into I. So AC circuits, just we have seen. So phi is equal to 0. So what is the phase angle? So 0. Now what is the power? Power P is equal to V into I into cos phi, for example, active power. So V into I into what is the angle? 0. Cos 0 is equal 1, that is equal P is equal V into I, only we have get it. Okay, the frequency of fluctuating power, that is equal second term, that is Vm by Im by 2 into cos 2 omega t. So it becomes a 0 at double frequency average value. Okay, so these are the regarding to the if the circuit is connected only resistance in the circuit. Okay, resistance is a small part. So we will see the inductance also. So what is that one time? So 21 minutes. Okay, so we will see that in the next class. Okay, thank you for listening my class. Okay, what we have seen in this class? So in this class we have seen that once pure resistance connected in AC circuits, what is the relation between the voltage and current, and what is the power consumed by the resistance. So what is the power consumed? Power consumed, we can write it, the P is equal to V into I into cos phi, but the cos phi value becomes the 0, that is equal to V into I, we got it power. Okay, that is the power. Now, so the power also we can calculate it by I square R. So our current we know, resistance we know, we can know the power. Power is equal in watts. Dear students, in case of resistance, pure resistance connected in the circuit, so during the positive cycle, it consumes the power. During the negative cycle, it consumes the power. So that power is represented by I square R. Or we can write it the V square by R. Or we can write it the P is equal to V into I. So such that we can find the these values. Okay. Now we will see the next component is sister. Okay, younger we want the elder sister behavior. Once if connected, if remove this value, if we connected the inductance value, what is the these relations, same relations. If remove the inductance, then connect the capacitance, what is the same relations, we will see. That means here pure resistance in the family, what will happen? Pure inductance, what will happen? Pure capacitance, what will happen? We are going to analyzing the circuits. Okay, so dear students, we will see the if inductance is connected, pure inductance is connected in the AC circuits, what is its behaviors. Okay, so thank you for listening my class, dear students.